In this video, I'm going to go through another example of converting the sum of two trig functions into a single cosine with an amplitude and a phase shift. Okay, so what we have here is another function that suppose could be the solution to a differential equation, and it comes up in the context of mechanical vibrations and resonance, for example. Here we have 3 times the sine of 2t minus 4 times cosine of 2t. And what I'd like to do is rewrite that as a single cosine function with an amplitude. And now there's one thing that we know for sure, because sine is periodic, sine of 2t is periodic with period pi, and cosine of 2t is periodic with period pi. We know that the function that we're going to write down here, the single cosine function, should also have the same period. So that means we're going to have the same frequency in front of the t, but we might have a phase shift phi. So how do we figure out what a and phi are? We use the same technique that I described in the previous video, and that is we first write down the amplitude, which will be the square root of 3 squared plus 4 squared, which is square root of 9 plus 16, which is 25. So the square root of 25 is 5. So the amplitude is 5. And now we rewrite f of t, factoring out that amplitude. So we put the 5 out in front, and now we get a 3 over 5 in front of the sine of 2t, minus 4 over 5 times the cosine of 2t. Okay, so now that we've factored out the amplitude here, we know that the coefficient on the sine and the coefficient on the cosine, when squared and added, come out to 1. That means that we can solve the equations that we got using our trig identity. So what was that trig identity? Well, let's just write it down in case you don't remember or you're not sure how to deal with this case with the 2 in there. So cosine of 2t minus phi is equal to the cosine of 2t times the cosine of phi plus the sine of 2t times the sine of phi. And now I have to try and match the pieces in the brackets to the thing on the right-hand side to determine what phi is. So you'll notice the cosine expression here has a cosine phi here, but a minus 4 over 5 here. So that means that we have to find a phi value so that cosine of phi is equal to minus 5 over 4. Sorry, minus 4 over 5. Similarly, the sine 2t has a sine of phi in front of it over here, but a 3 over 5 in front of it up there. And so to match those, we want to choose phi to satisfy both of these two at the same time. Now, on the unit circle, and we know that this cosine and sine are going to be on the unit circle because we divided by the right amplitude to ensure that the square of sum of the squares of these two are 1. So now we have to go in the negative direction in the x-coordinate because cosine of phi is the x-coordinate and sine of phi is the y-coordinate. So we go minus 5 over 4 in this direction, and then sine of phi is 3 over 5, that's positive, so we go up in this direction, and we draw our hypotenuse there. And we know that this height here is 3 over 5, and this line segment here, well, the coordinate of the endpoint of it is minus 4 over 5, but the length of it is 4 over 5. So this is not a special triangle, it's a scaled down version of a 3, 4, 5 triangle. And if you use your calculator to figure out what this corner value is, let's call that theta, then we find that theta is equal to 0.64 in radians. And so we need to determine what phi is, which is this angle here. So phi will just be equal to pi minus 0.64. And we could give a decimal value for that, which is 2.5 radians. So now we can rewrite f of t as 5 times the cosine of 2t minus 2.5.